Welcome back to the last video of this short tutorial on how to use PyMOL. In this video, what we're going to do is I'm going to investigate how this molecule here binds to this protein. To do that, we're going to look at hydrogen bonds. Does it have it? Does it make any hydrogen bonds? We're going to look at the surface interaction, charge interaction, sorry. We're going to look at what happens if I was to mutate residues in this binding pocket and measure the lengths between two atoms. So to start, is this a hydrophobic interaction or is this a hydrophilic interaction? Well, it's actually easier to work out than you think. Based on a load of oxygens and phosphates, you can probably infer it's going to be some sort of charge interaction. However, we're going to look at this in more detail and generate a charge map. How do you generate a charge map? If you go up to the action, generate, electrostatic interactions, and then this one. It'll take a bit of time to load. It will then generate a charge map, and you can see this is the charge map of the whole protein. Red is negatively charged, blue is positively charged, and you can see there is this really strong positively charged pocket. That automatically indicates that this is a charge interaction. Now, when you generate charge maps, it actually generates a new object. So you can turn this on and off and put this one back. And you can always bring this back at any time. So we now know it's a charge interaction. What residues are contributing to this charge interaction? Well, we can do that. We can show the sticks. And I'm also going to, as you can see, it's all one color. I'm actually going to color it by element. There we go. So now you can see if it's oxygens or nitrogens. So if you were to look here, it looks quite complicated, doesn't it? So remember using the focus view. I'm going to first center this. So actions center. Then focus view by scrolling, and you can see it's removed some of the background, and now you can see which residues are here. So what I want to know is what residues are interacting with this. The likelihood is these are going to be charge interactions and generate hydrogen bonds. So what we're going to do is we're going to click here. So we're going to click here. We're going to go to action, find, polar contact, and I'm going to put to any atom at this moment. And you can see the dotted yellow lines indicate hydrogen bonds. And it's making hydrogen bonds with quite a few of the residues. So what I'm going to do, I'm going to select all of these residues. And I'm now going to make a new selection. So action, rename selection. And these are the residues H bonds. And so I can now turn on and off that selection. So now in theory, what I can do is hide everything and just show these residues. If I want to know the name of any of these residues, I can just select them. It will appear up here. You clicked this residue, or I can drag this along and I can have a look. This is a lysine. Or I can right click on a residue and it'll tell me which residue it is. So let's say I wanted to work out what the distance between this atom here is and this atom here is. So we're going to use one of the first wizards. Wizard measurement. When you open up a wizard, you'll normally get a new list of tools down here, and it will give you a little instruction here. Please click on the first atom. Click on the second atom. Very simply, it's now given us the length. All of these measurements can be turned on and off. Important thing to note is when you use wizards is that once you've finished using the wizard, you've finished doing your measuring, you click done. Because if not, and you go, oh, I want to select this residue here, you think, oh, it's not. I'm not sure why it's not selecting, and then you click here, and it starts making more and more measurements. So you need to click done. Now we might be interested in, well, let's mutate some of these residues. So we'll go to the second wizard, mutagenesis. I want to change this to a leucine, which is a non-polar residue. And I'm going to mutate all of these to a leucine. What you can see here is the white is will be the new mutation. And the red circles indicate this atom is getting too close to here. These are clashes. There are different rotamers down here. You can see there's 5 states in total. It's selected state 3 for me. State 3 is the one which has the least number of clashes, the one which it would be preferable, but you can still flick between them. We can see that big clash, 3's, and then, you know, even bigger, for example. So we'll go back to 3 and we'll click apply. We'll go to here. We'll click apply. It will always pick the version which is best. Apply. So I've now changed them all to leucines. I'm done, so I'll click done, and I'm actually going to show the sticks back again and show the cartoon again. I'm going to hide the polar contacts. So now we've mutated all of the charged residues to non-polar residues. So let's see if how that's affected the charge map. So obviously, as you can see here, we need to generate a new charge map. So we're going to go to Action, Generate. And you can see the majority of the blue's gone. I've missed a few down here, but as it's telling you that it was these residues causing the charge interaction, now the likelihood is this may not work. So in this video, we've very quickly gone through the two wizards, so measurement and mutagenesis. We've also gone through how to generate a charge map, and we've also shown you how to generate hydrogen bonds, or how to find hydrogen bonds. So that is the end of the tutorial on how to use PyMOL. This should give you all the information you need to do the practicals during your undergraduate. And thank you for watching.